how many people are actually involved in this whole do-it-yourself, biohacking, biodesign world? I'm now going to call Chris. He's a biohacker in Slovenia. In a moment I will be talking to Christine. She works at the DNA Learning Center in New York and she has a lot of experience in working with citizens and biotechnology. Well, let me show you some estimations that we made. First of all, there are about 500 million people living in Europe. Out of those 500 million, I think about 50 million actually visit science centers and have some interest in science and maybe also in biotech. 5 million people, I think, are actually participating in the online citizen science projects like Zooniverse. And out of those 5 million people who are really engaged in citizen science, maybe 500,000 are actually providing resources and materials for doing science, like in the IBM World Community Grid program. And, well, to really actively spend time on citizen science, I think the best community to take as a reference is the bird watching community. Only in the UK there are already 50,000 people actively watching birds. And then an even smaller subset of people in Europe are actively engaged in do-it-yourself biohacking, biodesign. And I think it's safe to assume that about 5,000 people are actually doing that. Hi.
Hi, this is Christine speaking.
Hello, this is Peter.
Hi, how you doing?
Good, good, good. So yeah, first of all, I'd like to know a little bit more about your work at the DNA Learning Center and the barcoding project. Could you maybe share what's it about?
So yeah, sure. So DNA barcoding is actually, it was established a couple of years ago. So maybe I should start what DNA barcoding is first.
Yeah.
So DNA barcoding is a molecular technology that allows the identification of any biological species by looking at its DNA. So it's really democratizing species analysis, going away from memorizing phenotype, like how something's looking on the outside, going to a DNA structure. So there are certain genetic regions called diagnostic genes, and they can be used for everyone to identify every living thing. So that's what basically DNA barcoding is about. When I usually tell people about this, they ask us, so why is DNA barcoding important? And because we're running a big citizen science initiative since several years, the standard answer I usually give them is that DNA barcoding is a great tool to explore the environment, and it's used to detect food or medicinal mislabeling. And our project mission is for students to gain an intuitive understanding of the crucial interdependence between the health of humans and the health of the natural environment. So it's a really global approach, getting awareness out there. Why is biodiversity important? And because you can identify biodiversity based on your DNA barcoding. That's one aspect.
And how many people have been participating so far?
Well, a lot actually. So the Learning Center created and implemented it's a citizen science framework, and we started in 2010. And the framework is scalable, so meaning it works for a single citizen scientist who is working on one project, but we also have whole school classes joining, or even campaigns over several institutions and countries. So what we first did is we worked with DNA barcoding pioneers and stakeholders at universities like Rockefeller University and the American Museum of Natural History to design a robust but simple lab activity. And then in parallel, we developed an open access data analysis tool called DNA Subway, which is online. And we also we have a dedicated website. So this allows students to combine the in vivo, the in vitro, and the in silico analysis. So they move between fieldwork to lab work and bioinformatics in one single project. So that means we had actually a lot of students participating. We had more than 1,700 students working in 600 student teams. Every team is between 2 and 4 students, and they have been mentored by 400 teachers or scientists. Wow. So this means We had 175 schools in the New York City metropolitan area alone, and we also worked with 54 universities and cultural institutions, but also community labs like GenSpace in New York City. I think you heard about them. So they're one of our collaborators to tap into societies and communities. They would actually never ever go to a university like we are, because we are part of Cold Spring Harbor Laboratory. The cool thing about this is we actually reached a lot of underrepresented minorities in science. It's more than 30%. That means first-generation Americans, people actually are English language learners, women in science, a lot of African Americans and Latino Hispanics. So we were able to target these ones. And for the majority of the students or participants, it was the first research experience, which is also very nice because it's their gateway. It could be potentially their gateway to go in science and maybe stay in science. So this is the way how to learn skills and get excited and then go on and visit colleges and maybe, gonna be the next generation of scientists, actual living scientists, if you know the hashtag. Yeah. So out of those teams, we had more than 7,300 DNA samples processed. We have more than 13,000 DNA sequences and more than 2.6 million next generation sequencing reads. So it's a lot of data. Yeah. Students also publish, so that's one important aspect. We have publications authored by students in high-impact journals and more than 100 novel GenBank records. This means the data the students are generating is really high-quality data, and they make the data available for researchers. So people all over the world can go online, look at this database, and say, oh, okay, New York City student actually found this out, so maybe I use this data for my next project. And that's where we actually go full circle. It's not only like having citizen scientists involved in the beginning, but it's student-centered. They design their own idea, they figure out why it's important, they go to the field, they go to the lab, they actually work with bioinformatics, and then in the end they're going to publish something which really has a value for science, but also for the citizens. Right. So it's a nice contribution.
Yeah. And what have they discovered so far? What were some interesting findings?
Yeah, there's so many. But one of our favorites that we have been producing many interesting results. So in the first year, it was actually a science competition in New York City, and the grand prize winner found that ginkgo capsules they tested had no ginkgo DNA. So there was an absence of the label, the absence of the plant which should be on the label, but instead there was plenty of rice DNA. So it's total medicinal fraud. Whoa. And the same result was later supported by the New York State Attorney General. They used the same methodology like DNA barcoding, and they have been ordered to drugstores to stop selling a number of herbal supplements because DNA barcoding showed that they do not contain the advertised plant. So it was really mirrored by high research labs later on, but citizen scientists have been figuring out a couple of years earlier. They were 16, 17-year-old students, so that was great. And another project that I really like is because it's informative for maybe science policy. It's the illegal trade of seahorses. So we had a project using DNA barcoding to study the worldwide trade of seahorses online on eBay, but also in local New York City markets to check whether the vendors abide by trade regulations and sell endangered species. And we found that several vulnerable species of seahorses, they actually were sold internationally and domestically, and that the most domestically traded seahorses were actually under the 10 centimeter size protection limit. So these are just two examples, but we also had surveillance projects. I've been mentoring a student team looking at microbes and flu virus strains circulating on money bills in New York City. We didn't find any pathogenic microbes, but it's actually important if you have, let's say, the next outbreak of highly contagious flu virus, you can actually tap into citizen science to get more data. And we also have broad biodiversity projects in Cold Spring Harbor where students actually look at the ecology, look at the samples found in the harbor, and to compare the data to biodiversity studies that has been done in the late 1800s. So this comparison gives you a glimpse into the huge changes in the species that live in and around the waters of the harbor. I mean, I could go on and go on.
Well, these are very, very interesting examples.
These are the most, things that pop into my mind and actually had brought the most attention and had the hugest impact so far.
Yeah. Now, those are the things that I'm looking for, because the do-it-yourself citizen movement has been claiming a revolution or disruption of the biotech industry and society for a long time. I'm really curious to find concrete examples of what has been achieved, and this is, I think, a great one. But what does it take for someone to participate? What do you need to have in place, like in terms of infrastructure or background or skills?
Right, so we are providing the majority of the infrastructure. We have labs actually in New York City where students can come. We call them open labs. It's like an open access laboratory with all the equipment and reagents available. But what was needed in the beginning was actually making a website and training some teachers. So we have been partnering with the New York City Department of Education to really get teachers trained, because if you train teachers really well, it trickles down into your community. And then they could bring this technology back into the schools. So that was one thing we had to do. All the other things, so we provide, once they want to participate in urban barcoding, we actually have them working with the students on proposals. They submit proposals, we give them feedback, and then the majority of them is accepted into our urban barcode project every year. So it's between 50 and 100 teams every year. And we pay them sequencing. We give them reagents if needed. We also ship them to the schools. They can even borrow equipment like PCR machines, pipettes. So that's why I say it's a real nice framework. And it's scalable, so you can be a single person working on one citizen science project, and if we think it's an interesting idea and it hasn't been done in the past and it's actually good for your learning, we will support it. So that's what it takes. And it basically takes interest, because we train the teachers, but we also train students in prep courses. They make some labs at our laboratory, so they know how to pipette, and the majority, they're just really ready to move on after a couple of days and do this by themselves. So they own the projects, they come up with their own ideas, and they will never ever forget this experience later on, because it teaches them critical thinking and it teaches them, why science is important.
Yeah. And have there been participants from Europe, from our side of the
pond
as well?
So we have been helping actually a couple of universities to start this. I have been working with, maybe you know them, maybe you should reach out to them, or maybe I can connect you to Bruno Strasser from the University in Geneva.
Yes, he's one of the partners.
Bruno is actually he actually, I think he even found some novel species using DNA barcoding.
Right.
I have been talking to people in London. I think they're ready to start, but it's spreading. So I've been going to many European citizen science conferences and then just like try to give concrete examples, because that's what people have been looking for.
Yeah.
And that actually comes or loops into, how can policy help? So I mean, if you think about barcoding, policy, I think policy is already aware that this has a huge potential, because as of December 2016, DNA barcoding is now part of the United Nations Strategic Plan for Enhancing and Protecting Biodiversity, which is pretty big. So barcoding, it has led to the discovery of many overlooked species in Europe, in whole North America. The Canadians are doing pretty strong projects here too. And it also has been used to identify products in the marketplace, correct food mislabeling, natural health products, improve environmental monitoring, and measure environmental impacts of human activities. So because it has been identified as a great tool, not only for citizen scientists, but also like to protect biodiversity, then I would say funding is critical. Yeah. So if you can show the impact of citizen science on biodiversity, then I would just say, it might be easier to apply for funding.
Exactly.
But I think that's the answer you will get for every person. And then the second thing, what I would say is pretty classic, access. So in the US, obtaining sampling permits to bring students outside to collect samples from natural areas like parks, it's a super easy process. As an Austrian native, though, I know that many European countries, they would actually not allow such activities. So there are very strong regulations in place. So policymakers, they might consider changing strict regulations to allow citizen scientists access to those activities. And there are of course ways around it.
You cannot just take a scoop of earth or a plant from a mountain, or you cannot just simply take a sample from the environment. That's what you're saying, right?
Yes, so I would not be allowed to go to, let's say, collect some grasses from the park around the corner. I mean, here it's also not possible because everything which is actually in the park is protected by the New York State. So I have to obtain the sampling permit, which means, yeah, you lay out a plan. Okay, these are the specimens I want to investigate, and this is how much I'm gonna take, and of course I'm gonna do some non-invasive sampling. Okay, take as little as I would need, but it would be impossible for the majority of European countries because you would not be allowed to go just and sample. You would not be allowed technically to take any plants from the environment unless you have a very high level permit. So I think universities are able to do it, but not citizen scientists. That's what I have found. And I mean, there are ways around it. So you can collect something which is called eDNA or environmental DNA instead of actual specimen. But in my experience, this is it's less exciting and engaging for citizen scientists, and it's actually much more difficult to generate and look at data. So I would just say, maybe there might be some exemption for the strong regulations, but I think this is the future. Citizen science is going to be strong. It has ever been strong. And so I think no country should miss out on the power of citizen science. That's just my recommendation I want to give.
Yeah, I'm sure you are aware of these new pocket-sized DNA sequencing devices. There's Oxford Nanopore.
Yes.
Yeah, I've seen that they actually are developing modules that can fit on your mobile phone. Do you think that maybe in the near future, like every 1 out of 10 citizen would have such a device?
Yeah, so that's a good question because we have been testing these guys in the summer. So nanopore sequencing, it's a fantastic idea. It's still a matter of pricing. If I have to pay $1,000 to just have this device and run a couple of runs, sequencing runs, and then you need analysis software, you need to have the ability to code, then I would say it will take maybe 5 to 10 years until you have it really in your pocket, right? There are other open grade software resources called like mini PCRs that actually you can run PCR using your cell phone, or some I think Bento Lab actually even have like a model of having all the labs devices like a centrifuge, a PCR, and I think what else, and a heat block inside of one little device. So I think they're going to be the next generation. For next generation sequencing, where you have high throughput data, I think this will take some time. And this is mainly because you need a lot of computing power to look at this, and you will also need a lot of training. And I can always tell, all devices, they're going to be out there, but then it's a matter of training how you can use it. How many teachers are actually using smart boards right now? They all want to have a smart board or interactive devices, and then they don't know how to use it. I think that's just going to be taking a little bit of more time. The Learning Center, what we're doing here, we always try to make open access training sessions. So we are planning on building an online analysis pipeline also for next generation sequencing data. But again, we are like working very hard on this. And DNA Subway, what we're opening right now is, or what we have right now is for classical Sanger sequencing. So when you want to do it in a barcoding, you can always use this open access software. For next generation sequencing, it might just take a little bit longer. But yeah, I think people will do this in the future. It's just a matter of when you generate big data, what does it mean? And then you should actually have a good discussion about it.
Yeah, all right. Well, I can't wait personally until that will happen.
I know.
We have a small lab here in Amsterdam. We can do PCR, we can do all these things, but we'll start trying those Oxford Nanopore devices this summer as well to test them. This video series is of course about European policy, and I think this project is a great example of something that could be scaled up. Do you have a suggestion on how to approach that at the European Commission? Like, what would be the right type of angle to approach it? Is it more from an economic point of view, biodiversity point of view, or what would be your suggestion?
I would definitely say monitoring biodiversity is very important. It could also be seen as a very useful idea to train students for the future. Like if you give when you're going through one of our barcoding projects, you learn so many skills from observing nature, wet lab, critical thinking, proposal writing. We even have to presenting posters at our annual symposium, bioinformatics. So there are a lot of critical learning skills, and what we achieve is actually an attitude change towards science. So they might not have any idea about, oh, I don't know what science is about in the beginning, because the majority of our projects are actually with people that have never been doing any science project before.
Great.
But once they finish, it's a really wonderful experience because you have all those different aspects. You also have them working in teams. So I would definitely say it increases awareness for ecology, genetics, bioinformatics. These are all the skills you might need in the future.
And in terms of, let's say, an order of magnitude of funding, what would you think would be an effective amount to be able to scale this up, let's say, on the European scale? We have 350 million people in Europe. What would be an effective?
It depends what they're doing, you know. I mean, if it's next generation sequencing, it's going to be, of course, way more expensive. But I would say for every institution, I think 30,000 euros might be enough just to get it started. That's per institution. I don't know how many institutions you might have, but when in the beginning, we actually had to build a whole pipeline. You know, we had to train teachers, we paid them stipends, we paid a lot of sequencing, like 30 Sanger sequences per team, and we had 100 teams, so we budgeted $150,000.
Wow.
And that was just like for New York City. But we had a lot of great results, and then this is going strong since that time. So I would say ask maybe between 20 and 30,000 euros per institution. Yeah. To identify maybe one contact person to be trained and to have like open labs and have all the materials ready. And again, you can downscale by using open access software, like which ours is free, you know, and it's geared toward DNA barcoding. I don't know if they have already PCR machines they can borrow and lend out, and then all it needs is actually paying a person's salary who's actually going to be running it, and then paying the sequencing, because reagents can be cheap, but maybe you also pay some reagents.
Yeah. Okay.
So very similar that you have on, you know, when you go to community lab, you just try to get as many resources as possible.
Yeah, of course, but it's also good to have some kind of indication. I think across Europe, there may be 20 community biolabs in different cities. This would be, I think, a great example of a project that we could all collaborate on. And yeah, it's good to have some kind of indication of the amount of money that would take to realize that.
And I would talk to Bruno Strasser. Maybe Bruno has a better understanding how much it actually costs for him in Switzerland.
Yeah. All right. Well, actually, the first version of this policy paper will be presented at the University of Geneva. So, and organized at a conference, organized by him. So he will for sure be involved in this, and that will happen.
Great.
Okay.
New York City is also like very vibrant. I very often get emails from students. It's like, oh, I want to actually study the microbiome of sharks, and then I just tell them, sorry, I can't help you at this moment. And then I think 3 or 4 weeks later, I got an email from a scientist actually, oh, I'm actually found this school of sharks in Long Island. Do you have any people who want to work with me? So I try to connect them.
Wow.
And so it's just really fun. I mean, I think it would be a good idea to have databases out there. I want to study this, and is there maybe a researcher who can help me out? I think that's what has been missing. So you have this online blog systems, and Twitter is a good way to connect. But I think like bringing citizens and scientists together so they can actually just really connect over one idea, that might be something.
I think that's a great idea. That's also something that could be organized on a European level or a global level. Yeah, I think that's really a good idea. Because we have these type of mailing lists, people are connecting, that's all very informal and also, let's say, unstructured. But it's also due to the very nature, let's say, of the citizen science movement, because it's a bit chaotic, anarchistic anyway. So any
I know, one of
attempt to
those big
structure it
questions
is,
like once citizen scientists are involved, how do you retain them? Because most of them, they don't understand how long it takes to make sense of the data they're generating, like 1 year or a couple of months. So communication also has to be fostered, but that's nothing that can be like, it's informative for policy, but just for like scientists. So I'm a geneticist by training, and I had to learn, how to actually communicate this, in a way students are not jumping off. So I told me, this is actually going to be taking a couple of months, though. We're going to meet, and I give them little tokens on the way. But it's always very rewarding in the end if you just stay on the project and then really get either a publication or a talk, or have something that just really helped them to go into college. So that's...
Well, actually, every scientist should start a vlog, right? And then everybody can follow what they're doing. My first step would be try to convince the European Commission to fund these types of activities, and also to smoothen the regulation so that everybody can take samples and engage in this. And we'll take it from there. So in the project of Christine, the DNA barcoding project, we saw that citizen science and do-it-yourself biotech can have a huge impact. It can involve a lot of people and actually can actually discover mislabeling in food, assist in biomonitoring, introduce new people into science, training a next generation of scientists. So it can be very, very big. So for the policy paper, I believe this means that we have to spend even more time on clearly describing what biotech and citizen science together can do. And once that has been done, we can also more clearly convince them to change either policies or create more funding opportunities. But of course, there's also a different approach to money. Sometimes it's very easy to just demand our policymakers to fund citizen science projects. On the other hand, you could also think about creating a business out of do-it-yourself bio. So in my next video, I'm going to interview the manager of the Rebel Bio program in Ireland, which is a biotech incubation program for startups. And I'm also going to interview a startup that started here in our lab.